we'll explore the network protocols that power the web, revealing how they make our digital world work. Let's get started. First, let's take a look at what a network protocol is. A network protocol is a set of rules and conventions that govern how data is transmitted and received across a network. It defines how devices on a network communicate with each other, ensuring that data is sent, received, and interpreted correctly. These protocols establish the format of data packets, the way devices identify and connect with each other, and the methods for error checking and data retransmission. By adhering to these agreed-upon standards, different types of hardware and software can work together seamlessly, enabling reliable and efficient communication over local networks and the internet. Now, let's take a look at some of the most common network protocols. First, we have HTTP and HTTPS protocols. HTTP, or Hypertext Transfer Protocol, is the foundation of data communication on the web, enabling the transfer of web pages from servers to browsers. It operates as a request-response protocol, where a client, such as a web browser, sends a request to a server, and the server responds with the requested resources, like HTML pages, images, or other content. HTTPS, or Hypertext Transfer Protocol Secure, is the secure version of HTTP, which adds a layer of encryption using SSL and TLS to protect the data being transferred. This ensures that the communication between the client and server is encrypted and secure, safeguarding sensitive information from eavesdropping and tampering. Next, we have FTP. FTP, or File Transfer Protocol, is a standard network protocol used for transferring files between a client and a server over the internet or within a local network. It operates on a client-server model where the client initiates a connection to the server to upload or download files. FTP supports both anonymous access, where users don't need credentials, and authenticated access, which requires a username and password. Although widely used for file sharing, FTP lacks encryption, making it less secure for transferring sensitive data. For secure file transfers, protocols like FTPS or SFTP are recommended. Up next, we have SMTP. SMTP, or Simple Mail Transfer Protocol, is the standard protocol used for sending and relaying email messages across networks. It operates as a push protocol, where an email client like Outlook or Gmail connects to an SMTP server to send messages to the recipient's mail server. SMTP is responsible for ensuring that emails are correctly routed and delivered to the intended destination. While it handles outgoing mail, SMTP is often paired with protocols that manage the retrieval of incoming mail, like IMAP or POP3, which we'll cover later in the video. Like the previous protocols we covered, SMTP itself does not provide encryption, so secure versions like SMTPS are used to protect email content during transmission. Next, let's take a look at DNS. DNS, or Domain Name System, is a crucial protocol that translates human-readable domain names like www.youtube.com into IP addresses that computers use to locate and communicate with each other on the internet. Acting as the internet's phone book, DNS allows users to access websites using easy-to-remember names instead of complex numerical IP addresses. When a user enters a domain name into their browser, the DNS server looks up the corresponding IP address and directs the request to the appropriate web server. This process happens almost instantly, making it seamless for users to navigate the web. Coming up next, DHCP. DHCP, or Dynamic Host Configuration Protocol, is a network protocol that automatically assigns IP addresses and other network configuration parameters to devices on a network, allowing them to communicate efficiently. When a device, like a computer or smartphone, connects to a network, the DHCP server dynamically assigns it an available IP address from a predefined range, along with necessary details such as the subnet mask, default gateway, and DNS server. This automated process simplifies network management by eliminating the need for manual IP address configuration, reducing conflicts and ensuring that each device has the correct network settings to operate smoothly. Moving forward, we have SSH. SSH, or Secure Shell, is a network protocol used to securely access and manage remote servers and devices over an unsecured network. It provides a secure channel through which users can execute commands, transfer files, and perform administrative tasks on remote machines. SSH encrypts all data exchanged between the client and server, protecting it from eavesdropping and tampering. By using strong authentication methods, such as passwords or cryptographic keys, SSH ensures that only authorized users can access the remote system. This makes SSH an essential tool for secure remote administration and secure data transfer. For more information on cryptography and encryption, feel free to check out our video on that topic in the video description. Now let's take a look at TCP/IP. TCP/IP, or Transmission Control Protocol/Internet Protocol, is a foundational suite of protocols that underpins most modern networks, including the Internet. TCP/IP enables reliable data transmission by breaking data into packets, ensuring they arrive in order, and handling any errors that occur during transmission. The IP part of the suite handles addressing and routing, ensuring packets reach their correct destination across diverse networks. Together, TCP/IP facilitates robust, scalable, and efficient communication between devices, making it essential for network connectivity and Internet functionality. For a more detailed overview of IP addresses, be sure to check out our separate video on that topic. Next, we have POP3 and IMAP. POP3, or Post Office Protocol 3, and IMAP, or Internet Message Access Protocol, are two protocols that help you access your emails from a mail server. POP3 downloads emails to your device and usually removes them from the server so you can read them offline, but it limits access from other devices. IMAP, on the other hand, keeps your emails on the server and syncs them across all your devices so you can access your messages from anywhere. SMTP, which we covered earlier in the video, is used to send emails to the server, while POP3 and IMAP are used to retrieve them from the server. Together, these protocols work to ensure you can send and receive emails effectively. Coming up next, UDP. UDP, or User Datagram Protocol, is a communication protocol used in computer networks that allows for fast and connectionless data transmission. Unlike TCP, UDP does not establish a connection before sending data, nor does it guarantee delivery, order, or error checking of packets. This makes UDP more efficient for applications where speed is critical and data loss is acceptable, such as live video streaming, online gaming, or voice-over-IP services. While it's less reliable than TCP, UDP's simplicity and low overhead make it ideal for real-time applications where performance is more important than accuracy. Now let's take a look at ARP. ARP, or Address Resolution Protocol, is a network protocol used to map an IP address to a physical MAC address within a local network. When a device wants to communicate with another device on the same network, it needs to know the recipient's MAC address. ARP helps by sending out a broadcast request asking, "Who has this IP address?" The device with the matching IP address responds with its MAC address, allowing the communication to proceed. ARP is essential for enabling seamless communication between devices on a local network. To learn more about how MAC addresses work, check out our separate video, which you'll find linked in the video description. Moving forward, we have Telnet. Telnet is an older network protocol that allows users to remotely access and manage devices over a network using a command line interface. Unlike more modern protocols, Telnet does not encrypt the data being transmitted, which includes sensitive information like login credentials. Because of this lack of security, Telnet is generally considered outdated and insecure, making it less suitable for use in today's environments where security is a priority. It was briefly mentioned in our previous video on firewalls as an example of a protocol that can be easily exploited by attackers if not properly secured. Next on our list is SNMP. SNMP, or Simple Network Management Protocol, is a network protocol used for managing and monitoring network devices, such as routers, switches, and servers. It allows network administrators to collect performance data, monitor device status, and configure network hardware from a centralized management system. SNMP operates using a client-server model where the managed devices, agents, send information to a network management system, NMS, upon request or periodically. This protocol helps in maintaining network performance and troubleshooting issues, making it a crucial tool for network administration. Coming up next, ICMP. ICMP, or Internet Control Message Protocol, is a network protocol used to send error messages and operational information about network communication. It operates as part of the Internet Protocol Suite and is essential for diagnosing and managing network issues. ICMP helps in troubleshooting network connectivity problems, by providing feedback on the status of data transmission. For example, tools like Ping and Traceroute use ICMP to test the reachability of network devices and to determine the path that data takes across the network. By reporting errors and network conditions, ICMP aids in maintaining efficient and reliable network operations. Next, let's take a look at NTP. NTP, or Network Time Protocol, is a network protocol used to synchronize the clocks of computers and network devices over a network. It ensures that all devices on a network have a consistent and accurate time, which is crucial for various applications such as logging events, coordinating transactions, and scheduling tasks. NTP operates by allowing devices to communicate with time servers which provide the correct time based on highly accurate sources like atomic clocks. By maintaining synchronized time across a network, NTP helps in preventing errors and inconsistencies that could arise from time discrepancies, thereby ensuring smooth and reliable operations. And lastly, let's take a look at RIP and OSPF. RIP, or Routing Information Protocol, and OSPF, or Open Shortest Path First, are two widely used routing protocols in computer networks. RIP is a simpler, distance vector protocol that determines the best path for data by counting the number of hops between the source and destination. However, it has limitations in larger networks due to its slower convergence and maximum hop limit of 15. OSPF, on the other hand, is a more advanced, link-state protocol that uses a cost-based metric to determine the shortest and most efficient path for data. It's faster, more scalable, and better suited for complex networks. In conclusion, understanding network protocols is essential for grasping how data travels across networks, ensuring smooth communication between devices. These protocols, from basic ones like TCP/IP to specialized ones like RIP and OSPF, form the backbone of Internet functionality and network management. Whether you're dealing with email, file transfers, or routing data, knowing how these protocols work gives you the insight needed to manage, secure, and optimize your network effectively. With this knowledge, you can better appreciate the complexity and efficiency of modern digital communication. This concludes our exploration of network protocols. If you enjoyed it, consider subscribing to our channel and liking the video.